Our last problem that we have here, again, making a sketch. Again, as we could see directionally, we want to identify the shape, the max R value, the number of zeros, specifically the zeros, significant points, and sketch. So that's a little misleading. Again, I copied and pasted here. You will not be asked to find the specific zeros tomorrow on your Limason. So again, the other stuff though, that's going to hold true. We need to identify the shape, we need to identify the max R value, how many zeros we have, as well as the significant points. So with this particular problem, first thing that's worth noticing is we know it's going to be a Limason. Again, absolutely no doubt about that because of this subtraction problem in the middle. Further, we know that this is going to, because it's a cosine problem, we know that this is going to be horizontal. And we know that it's going to point to the left. The reason it points to the left is because it's a subtraction problem. The reason it's horizontal, again, is because it's a cosine problem. Had this been a sine problem, it would have opened up or down. Had it been a sine problem with a subtraction symbol, it would have been pointing downward. Sine problem with addition, it would have been pointing upward. Had this been cosine with addition, it just would have been pointing to the right. So that's just sort of the kind of the lead-in. We also know A and B values here, so I know that A is equal to 2, B is also equal to 2. Remember, we always think absolute value here. So if A over B is equal to 2 over 2, which is 1, now we know unequivocally that A over B equals 1. So for that reason, or with that in mind, maybe it's a better way to say this, anytime A over B is equal to 1, we're talking about a cardioid. Limason. The maximum R value, again, this is where we have to, different than our Rose curve, we can't just say it's equal to A or it's equal to B or whatever, but this is where we're actually going to find the absolute value of A plus the absolute value of B. So in this particular case, we're finding the absolute value of 2 plus the absolute value of 2. So for that reason, we could say that our max R value is going to be 4. Now the difference between Limason and the Rose curve is that in the Rose curve, that max R value, that's going to be obtained or touched or hit as many times as we have petals. For a Limason, that's not necessarily going to be the case. So we know that we have a max R value of 4. That's just kind of a, oh, hey, that's good to know type thing. As far as our significant points are concerned, again, it's going to be beneficial to us to actually write in, or to not write in, sorry, but to create my T-chart before trying to identify the number of zeros and things of that nature. So the good news when it comes to the T-chart is that with any Limason, whether it's a cardioid, inner loop, dimple, or convex, we're always going to use the same 5 theta values. So we get those values are 0, pi over 2 pi, 3 pi over 2, and 2 pi. So these are always going to be the same values, just again on repeat over and over and over. So what we're plugging into, if R is equal to 2 minus 2 cosine theta, we're going to literally do this problem 5 times with 5 different theta values. So in doing so, we're going to say that R is equal to 2 minus 2 times the cosine of 0. So as we're looking at this, I know that the cosine of 0, remembering your unit circle, of course, and cosine of 0, just so we're all looking at the same place, the cosine is going to be positive. So R is equal to 2 minus 2 times 1. We, of course, know that 2 times 1 is 2, so we're looking at 2 minus 2. So now I know that R is equal to 0. We're going to do the exact same thing, except on this second round, we're going to plug pi over 2 in place for cosine, or I'm sorry, in place for theta. So now we're looking on my unit circle at pi over 2. At the cosine value there, R is going to be equal to 2 minus 2 times. We know that the cosine of pi over 2 is 0. So 2 times 0, of course, is 0. So we're looking at 2 minus 0, at which point now I know that's the worst 2 ever. But R is equal to a positive 2. Same process, this time, third time, looks like we're going to plug pi in place for theta, which puts us over here. Cosine of pi we know is -1, so if R is equal to 2 minus 2 times -1, and cleaning that up, we're talking about -2 times -1, 2 plus 2, now I know that my R value is 4. And I'm sure we know the pattern by now. I'm sure that it's probably unnecessary that you're watching me do this. But r is equal to 2 minus 2 times, now the cosine of 3 pi over 2. Okay, cosine of my x term is going to still be 0. So in cleaning this up, 2 minus 0, r is again going to be 2. And lastly, probably don't really even need to do this, it's just a way of checking. The cosine of 2 pi, excuse me, that puts us around full circles, so the cosine of 2 pi is again going to be 1. So if r is equal to 2 minus 2, again, we can say that r is equal to 0. It's always beneficial for us to complete all 5 values on that t-chart, and I think once we continue on here, that's going to help. So again, I'm going to erase some of this stuff here. Definitely don't want to erase the t-chart. Again, we just worked hard at obtaining that. So we're going to go ahead and start plotting our points. So on the angular line of 0, my r value is 0. On the angular line of pi over 2, my r value is 2. On the angular line of pi, my r value is 4. On the angular line of 3 pi over 2, my r value is 2. And to show that we came full circle, angular line of 2 pi, my r value is 0. So now we cannot lose sight of the fact that we claimed that this was going to be a cardioid. So that means that when we're drawing our sketch, we have to make this thing look like a cardioid. So it's also going to be beneficial for us to remember that this is a cosine problem. And if it's a cosine problem, I have to begin on the polar axis. So whether this was sine or cosine, I guess, obviously, if we really think about it, we know where we would have started, horizontal, vertical, whatever. But on the polar axis, the point that we have happens to be on the pole. So if I'm counting the times that I touch the pole here, we have 1 and 2. And I'm kind of regretting the way that I made that sketch. I would encourage you, if this is a cardioid, I would encourage you to probably overemphasize it. So make it absolutely clear that, yes, this is supposed to be a cardioid, it's supposed to be heart-shaped. Again, now when we look at it, nobody's going to mistake that for being dimpled or anything else, but again, we could also quickly have gotten there that there were 2 zeros. Now, I think that the easier way to look at this, remember as we talked about in class today, that with an inner loop limacon, that's one that you can't really follow, but for our purposes, when we look back to our t-chart, all that we're really looking for the number of zeros, it's talking about when does r equal 0. And it looks like we have that happening 2 times. Therefore, we have 2 zeros. So last thing that we need to do after we make the sketch and we've identified the shape, the max r value, and the number of zeros, so we've got to come up with the significant points. So again, by creating a solid t-chart, we've already done that. So my significant points are at 0, 0. They're 2 comma pi over 2, 4 comma pi, and lastly we could say it's at 2 comma 3 pi over 2. But those are my significant points. We have our sketch. We do not have to identify the specific zeros or anything of that nature. Again, we have everything that we need here. All right. So hopefully we're feeling pretty good about all these types of problems. Hopefully we saw earlier in the video the little symbol that you're supposed to make to showcase that you've actually watched the podcast. But really, make sure that you're studying. Make sure that you know your stuff. Remember, there are no formulas that are to be given tomorrow. No formula sheets or anything like that. So again, any little formulas, equations that you think that you're going to need, it's going to be up to you to bring those to class tomorrow. Again, in your mind. So again, study hard. Let me know if we have any specific questions, and we'll try to get them answered before tomorrow's quiz.